All right, let's dive right into this explainer and demystify exactly how economists take incredibly abstract concepts, like the cost of living, and calculate them by building an index number entirely from the ground up. Whether it's the consumer price index flashing across your newsfeed or stock market indices like the Sensex driving financial headlines, these numbers literally dictate economic policy, wages, and our whole understanding of inflation. But how do we actually build them? Well, today we're going to act as statistical architects and construct one together. Here's the builder's blueprint for today's explainer. First, what are index numbers? Second, step 1, purpose and selection. Third, step 2, the base year. Fourth, step 3, weights and averages. Fifth, step 4, the final formula. And finally, the limitations of the index.
So, let's start with section 1. What are index numbers? Laying the foundation.
Now, this concept actually dates way back to the 1700s, when people were comparing the prices of wheat and cloth just to understand how living costs were changing over time. As statisticians Croxton and Cowden brilliantly defined it, an index number isn't something you can measure directly. I mean, you can't put the economy on a bathroom scale, right? Or measure inflation with a ruler. Instead, it's a relative measure of net change between two entirely different time periods. It basically acts as a highly specialized average to gauge trends across a massive group of variables. Think of these numbers as the absolutely indispensable barometers of economic activity.
Moving right along to section 2. Step 1, purpose and selection. Gathering our materials.
You can't build a house without knowing who you're building it for. And you certainly can build an index with a highly specific goal. Imagine a researcher with a clipboard defining their exact purpose right out of the gate: to measure the cost of living for urban families. Because it is physically impossible to track every single item sold in a country, they've got to carefully pick a representative sample of everyday goods, things like wheat, rice, standard clothing, that genuinely reflect real-world tastes and habits. Notice how they actively skip the luxury items? That's because those don't fit a typical urban family's budget and would just skew the results. Finally, they hit up registered fair price shops across multiple markets to gather entirely unbiased, accurate price data. Because if your raw data is flawed at this stage, the entire mathematical structure is going to collapse.
Section 3. Step 2. The base year. Setting the anchor. With our materials selected, we need to pour the concrete anchor for our economic structure. In statistics, this is known as the base year. Now, our reference point absolutely must be a normal, stable past year. Let's just say 2005 for this example. This year has to be completely free from unusual crises. Think about it. If we anchor our calculations to a totally abnormal year filled with natural calamities, wars, or massive economic depressions, our entire index is going to be statistically crooked. And, as an aside, this anchor shouldn't be too incredibly far in the past either, which is exactly why organizations frequently update their base years to account for our ever-changing economic landscape. So here's the crucial takeaway. Once we lock in that perfectly stable base year, its index value is universally assumed to be exactly 100. This is our starting line, the magic number. When we look at prices or production levels in our current year, we are essentially just asking, how does today stack up against our perfect baseline of 100? Let's jump to section 4. Step 3, weights and averages, the load-bearing math. Now, because all items are definitely not of equal importance to a family's budget, we can't just treat them equally in our math. Look at the scale here. Different items receive literal weight blocks based on their real-world importance. Essential, everyday items like your food grain packets get massive, heavy weight blocks. On the flip side, minor, less essential decorative items get tiny little weights. A mathematical calculator then crunches these numbers, typically using a simple arithmetic mean. Why? Simply because it's reliable and super straightforward to compute.
Section 5. Step 4. The final formula. Executing the blueprint. Let's see how all this prep work builds into the completed structure. Notice how cleanly all our carefully chosen variables come together into a single, elegant equation, the simple price index formula. P01 right there is our finished index number. We take the sum of our current year prices, that's the sigma P1 on the top, and we divide it by the sum of prices from our stable base year, the sigma P0 on the bottom. Multiply the whole thing by 100 and boom, you have your percentage-based barometer.
To make this concrete, let's plug in some actual data. By taking these 4 everyday commodities from our source data, we'll just label them A, B, C, and D. We can see exactly how the math plays out. We add up all the base year prices in our P0 column, giving us a neat total of 220. Then we do the same for the current year prices in our P1 column, which totals 300. Now, obviously, the upward trend is super visible just looking at it, but the formula is going to give us the exact standardized metric we need.
Processing those sums through our formula, so taking 300, dividing it by 220, and multiplying by 100, gives us our completely accurate economic index number of 136.36. Remember, because our base here was perfectly set at 100, this new number indicates a definitive, undeniable 36.36% rise in the price of this specific basket of goods. And this right here is exactly how governments measure inflation to adjust national policies or figure out dearness allowances for employees. It's a real game changer.
Finally, Section 6, Limitations of the Index, the inspection. However, just like any massive complex building, our finished index needs a really thorough structural inspection. Because let's be honest, no statistical tool is completely flawless. Since they rely heavily on samples, they're always going to be subject to sampling errors. We simply cannot include every single commodity in existence. They are also super susceptible to data bias if the price reporting agencies happen to provide incomplete or flawed information. Plus, there's a real risk of misuse. Imagine a business cherry-picking a highly favorable but totally abnormal base year just to artificially inflate how well they seem to be performing. And on top of all that, while arithmetic formulas are static, the reality is that the economy and our consumer tastes are rapidly shifting every single day.
So, as we wrap up this explainer, we are left pondering a pretty fascinating dilemma. We've just seen the incredible logic, math, and structure required to build an index number from scratch, literally turning thousands of complex price points into a single actionable metric. But in a fast-paced, dynamic world where our personal habits are constantly evolving, can a single generalized index number ever truly capture your totally unique individual cost of living? Definitely keep that in mind the next time you see a massive inflation headline cross your screen.